In this video, I'm going to demonstrate how you could use Napier's rods or Napier's bones to multiply numbers involving numbers that have more than one digit. So how do we use Napier's bones or Napier's rods to compute multiplication where I have a 3-digit and a 2-digit number? So it's basically going to be a 2-digit multiplication, because typically when we use the rods or bones, whichever one you want to call them, I usually look for the number that has the most digits and line up the bones or rods based on them. So when I set this up, I'm going to set up to 825 with these bones, the index being 1. And so the index is basically the number I'm multiplying it by at that given instance. Now there's two numbers I'm going to have to multiply it by. I'm going to have to multiply it by a 4 and by a 7 at some point. In order to use Napier's bones to do this, because it's more or less designed to do this lattice multiplication for a single digit. And basically that's what this is. It's just lattice multiplication, just slightly different again. So I want to think of 825 as 825 times 47 is 825 times 40 plus 7, which is, splitting it up. And the 40 becomes 4 times 10. So the two multiplications I really want to focus my attention on are the 825 times 4 and the 825 times 7. And since I'm splitting it up this way, it really doesn't matter which one I do first at this point. So I'm going to look at doing the 825 times 4 first. So I'm going to look at the index here, and I can see the numbers that are here. Now, when I look at these lattices, I'm going to go by diagonals. So this diagonal would be the ones position. This would be the tens position. This would be the hundreds position. This would be the thousands position. So 825 times 4 would be 3 times 10 to the third, plus 2 plus 0 times 10 squared, plus 8 plus 2 times 10, plus 0 times 1. And so when I work those out, I get 3,300. So this number, this value in here is going to get replaced with 3,300, which I'm going to multiply by 10 eventually. Now I'm going to use the bones to do this 825 times 7. So I'm going to move my attention down to the index of 7, because that's the number I want to multiply 825 by now. And again, this diagonal is the ones, this one is the tens, hundreds, and thousands. So I'm going to have 5 times 10 to the third, which is 1,000, plus 6 plus 1 times 10 squared, plus 4 plus 3 times 10 to the first, plus 5 times 10 to the 0, which is, of course, just 1. And so when I work these out, I get 5,000 plus 700 plus 70 plus 5, which is 5,775, which I put up there. So now, it's a much simpler problem now. I'm going to multiply this by 10, which basically comes down to me just putting an additional 0 on it. So I have 33,000 plus 5,575, which gives me 38,575, which is what you would get on the calculator as well. But this was something that was developed long before calculators even came around. So let's move on to a situation where I would multiply by 3 digits. It works very similarly. Again, I'm going to set up the 3644 with the bones, because it has more digits than the 613. And so when I look at this, I'm going to do 3644 times 613, which I can think of it as 3644 times 600 plus 10 plus 3, which is the same thing as 3644 times 6 times 100, plus 3644 times 10, plus 3644 times 3. Now this 3644 times 10, I really don't have to do any special work for, because multiplying by 10 is one of the ones that most students tend to remember, because all I'm going to be doing is adding a 0 at the end of it. But I want to group this with the 3644 times 6, because that's what the bones can help me work with. This becomes 36,440, so that's pretty straightforward. And of course the other thing I'm going to use the bones to do is 3644 times 3. So now I'm going to look at the index of 6. And this diagonal here would be my ones, my tens or 10 to the first, my 10 to the second, my 10 to the third or thousands, my 10 to the fourth or 10 thousands. So 3644 times 6 I'm going to have 1 times 10 to the 4th plus 8 plus 3 times 10 cubed plus 6 plus 2 times 10 squared plus 4 plus 2 times 10 to the 1st plus 4 times 10 to the 0. So these work out to be 10,000, 11,860 plus 4. When I add those together, I get 21,864. So that takes the place of this in here. Again, the times 100 I haven't done yet. The 36,440 is what I got by multiplying this by 10, which is pretty straightforward. Don't have to use the bones for that. But now I want to do this multiplication here, so I'm going to use the index of 3. Again, this is my 1s, my 10 to the 1st, 10 to the 2nd, 10 to the 3rd, 10 to the 4th. So there is no 10 to the 4th, so I'm not going to worry about, multiplying anything by 10 to the 4th. I have 9 plus 1 times 10 cubed, plus 8 plus 1 times 10 squared, plus 2 plus 1 times 10 to the 1st, plus 2 times 10 to the 0. And so what that gives me is 10,000 plus 900 plus 30 plus 2, which is 10,932. Now I'm going to multiply this by 100, which just basically means me putting 2 zeros at the end of this. And I'm going to add these three numbers together, and I get 2,233,772. So obviously this method is not easier than just plugging it into a calculator, but you can see how early methods were very effective in making a complicated problem seem a little less complicated along the way. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.